communicating technological life. And we look around our own solar system and we see that of all the planets, there's only one that's inhabited. And so naturally we think that finding another Earth-like planet is, identifying a site that's at least friendly here for the evolution of life. So the mission, the primary goal of Kepler mission was to statistically assess the occurrence of these small terrestrial worlds. And I remember in March of 2009, when I was here, right after the Kepler mission launched, and I remember commenting that the planets would begin to roll out of the Kepler mission like an assembly line, and that in the first year we could expect to see Jovian mass planets or Jovian-sized planets, and after 2 or 3 years we'd see the Neptunes begin to roll out, and then finally the Earths. So I'm amazed to sit here today and see that Kepler is actually reaching the milestone discoveries faster, certainly, than I anticipated. Kepler has blown the lid off of everything that we know about extrasolar planets. And this week, to me, feels very different than last week did. And I'll tell you, summarize, actually, the 3 reasons that I say that. So first of all, from the Doppler planet searches, we could see that the gas giant planets like Jupiter were less common than the low-mass planets. We could see a mountainous sort of rise towards smaller and smaller or lower and lower mass planets. But our detection technique was hitting a wall just because of the precision of our measurements. And so we were at the point we were pounding away right now on this wall, trying to shake out a few planets that are, 2, 3, 4, 5 times the mass of the Earth, the super Earth regime. But our statistics there are not so good. And so what Kepler has done is it's extended a bridge that crosses this gap in our knowledge of what kind of small planets form. Still, the amazing thing to remember is that the detection of large planets or massive planets is always going to be easier than the detection of the small guys. And so what that means is that the statistics that Kepler has gained, even on the exoplanet candidates, maybe 20% of the candidates won't pan out. But statistically, we can see that we understand the fraction, the rate of occurrence of the massive planets from Jupiter, I think, all the way down to Neptune, actually. Those numbers are solid. We can take those numbers to the bank. That's pretty amazing. It's impressive, right, that the number of small planets is growing in a region of parameter space that theoreticians actually predicted might be a planet desert. The second amazing thing is that it's really difficult to untangle the signals from multiple planet systems. So it's worth reemphasizing that Kepler now shows that something like almost 1 in 5 of their stars with transiting planets hosts at least one other planet. And Kepler 11, which was just presented by Jack Lissauer today, is an absolutely staggering result. With 5 low-mass planets in the system, this discovery is as momentous as 51 Peg was in 1995. It shows that planetary systems with several small planets like our own seem to be common. And then the third point is that Kepler's really reaching out into a different part of the Milky Way galaxy than we're observing with the Doppler technique, our own nearby neighborhood. And I think it shows us that the adjacent neighborhoods in the galaxy look a lot like our own neighborhood. And so I think that's encouraging and important if we're trying to make extrapolations about the formation of planets elsewhere and perhaps life. So I can also actually provide some insight about the enthusiasm of the public for the Kepler data. At Yale University, we were so excited when we saw the Kepler light curves that we teamed up with the Citizen Science Alliance, who host Milky Way Galaxy Zoo, among other Zooniverse projects, to let the public participate in discovering planets at planethunters.org. When we started the project, we discussed it among ourselves, and we really thought there was about a 50-50 chance that this project would completely flop because, Galaxy Zoo shows beautiful pictures that people get to look at. We're showing time series brightness measurements of stars. But in just a few short weeks, we have over 16,000 dedicated users, and they send their greetings to us from Turkey, Russia, Poland, Spain, the Canary Islands, Italy, Brazil, Argentina, Chile, one country after another. It's amazing. The users have made more than 1.3 million classifications just using the first release of 35 days of public release data. They've identified hundreds of solid transiting planet candidates and eclipsing binary systems that weren't published before. So, of course, they're very eager now to see the list that will be coming out and see if they have any matches. We're really excited and appreciative that 12 hours ago, NASA and the Kepler mission has poured essentially quadrupled the amount of public release data into the archive on an accelerated schedule. This is really wonderful. At planethunters.org, we hear from teachers who are using Kepler data through the Planet Hunter interface in their school curriculum, from students who are having fun searching for this needle in a haystack just because they know the payoff is going to be so enormous. I had one of the Planet Hunters email me yesterday, and he or she said, that they had found 4 transiting planets and they felt so proud. And another person commented that they were going back to school now, that they'd seen the data and they wanted to learn more and they were returning to school. But really the dominant recurring theme that we hear from the public is that they're excited because they get to contribute to real research and they have a sense that they're a part of history. They understand the importance of the Kepler data. And I want to just echo that and say that also I feel this is an incredible historic moment and just want to thank the entire Kepler team for this treasure chest of data that they've provided. So back to Trent.
Thanks very much, Deborah. Okay, let's jump into the question and answer session. Just a reminder for everyone in the audience to please just wait until we get a microphone to you. There should be 2 running on either side. And please identify yourself and your media affiliation before you ask your question. For everyone online, please try to direct your question at least to a panelist to help avoid some confusion. And for those joining by phone, you can signal the operator that you have a question by pushing the *1 keys on your telephone. And I understand we have one question here in the audience. So
yes, Randy Shostak, reporter with EOS, the newspaper of the American Geophysical Union. Fantastic results. I wonder if panelists can comment on how